All right, hello everyone and welcome. My name is Reva Ramadurai and I'm the director of the Thermo Fisher Scientific Junior Innovators Challenge. And I'm here with my colleagues Alex Grace and Jenna DeLuca, and you'll hear from them in just a bit. And we're also glad that you could join us for today's webinar. Today, our webinar is tailored just for educators, but it is still applicable to mentors, parents and guardians, and other adults that are working to support students through the Thermo Fisher JIC. So first, before we dive into things, want to thank you all for doing the work you do to promote STEM and scientific research to the young people that you work with. It's so important and we couldn't do our jobs without y'all. So today we're going to go through the quick basics of the competition for those of you that might not be as familiar with Thermo Fisher JIC. And we're also going to share our advice for supporting your students throughout the process, from opening their application to submitting it. Um, and the last note before we get started, I just want to point out that we have several other webinars here on our YouTube channel. If you or your students are looking for more information about the competition, we have walkthrough videos of each task of the application that might be helpful for your students. We have a webinar that we did last year for teachers, and tons more information. So definitely check out our YouTube channel after this if you have some questions that don't get answered or new questions that pop up. So as we're going today, if you do have a YouTube account, you can also feel free to type in your questions into the live chat box on the right-hand side of the screen, and we'll be answering questions throughout via chat, and then we'll also have some time at the end to take them as well. And you can always email us at jic@societyforscience.org at any time after this webinar as well. All right, so now we're going to go ahead and get started. Oops. Well, before we talk about the competition, I'm going to talk a little bit about Society for Science, which is the organization that we all work for. The Society is a nonprofit dedicated to expanding scientific literacy, effective STEM education, and scientific research. And the Society's vision is to promote the understanding and appreciation of science and the vital role it plays in human advancement. We have 3 competitions that are our main flagship competitions, which are the Thermo Fisher JIC, the Regeneron International Science and Engineering Fair that is coming up next week. That is for high school students, both in the US and in our affiliated fair network abroad. And we have the Regeneron Science Talent Search, which is the nation's oldest and most prestigious science and math competition for high school seniors. We also publish award-winning flagship magazines, Science News, and Science News Explorers. And the goal of both of these publications are to get scientific research in the hands of the general public in a digestible way. And Science News Explorers in particular is geared towards middle school level and younger students, their parents and teachers as well. We also wouldn't be here without our friends at Thermo Fisher Scientific, who are the title sponsor for our Thermo Fisher JIC program. All right, so now a little bit about the competition for those that are new to us. So Thermo Fisher JIC is the premier national STEM research competition for 6th, 7th, and 8th grade students. It was formerly known as Broadcom Masters from 2011 to 2022. And the Discovery Channel Young Scientist Challenge prior to that, so we have been around for quite a while now. To qualify, students must first place within the top 10% in a society-affiliated science fair. So hopefully, if you're here, that means your students have already done that this year. And ultimately, finalists who, after going online, completing the application, and doing all of that by the June 10th deadline, are invited to spend a week in Washington, D.C. in October, showcasing their research projects and competing in hands-on STEM activities in teams. Oh, looks like my slides got rearranged just a little bit, so we're going to skip through those. So a little bit more about JIC. So there's kind of two main components to the program. The first part is students get to practice their scientific writing, critical thinking, and creativity within the application. That's the stage that your nominees are in now. Um, from here, we get the students have the chance, after completing their applications, to be selected as one of the top 300 junior innovators or 30 finalists. The different stages of the Thermo Fisher JIC, we have kind of four different stages that we categorize our students in. The first being the nominees. So these are your students right now. Nominees are the top 10% of 6th through 8th graders that are named from the local fairs. The Society for Science affiliates with about 300 middle school level fairs across the country each year. And nominees get a certificate, digital packets that tell them about information about how to apply in the competition in general. And we encourage them throughout the spring to apply online. Once a student submits their application by the June 10th deadline, they are considered entrants. And entrants are also considered alumni of the Society for Science. So that opens up a whole slew of opportunities to meet fellow alumni at the Society for Science. There's a lot of virtual programming that we do throughout the year and even some in-person meetup events, depending on where your location is. And then at each of our competitions, we try to get our alumni together as well. So if you have students, that will continue their research into ISEF, we'll do an alumni mixer at ISEF each year as well. Something to look forward to. And all students that complete their application by the deadline get a prize package over the summer in the mail. That includes a t-shirt and drawings for more prizes. The top 300 junior innovators are then announced on September 2nd. So we have a team of evaluators and judges that go through all of the applications that we get online and select those top 300. These students receive $125 courtesy of DOW STEM, and they also get a special prize package. Teachers of the top 300 junior innovators also get a prize package and a subscription to Science News Explorers that includes print copies that will be sent to you to use in your classroom. The 30 finalists, like I said before, are then invited to Washington, D.C. For finals week. Each finalist is awarded $500 and $1,000 to each school of the finalists to be used for STEM initiatives. So what exactly does it mean to be a finalist? This competition is very unique in what the students are judged on. They're announced this year on September 16th and will be held, finals week is held October 23rd through the 28th. So in addition to the research project, I mentioned this before, but the students compete in team challenges. And this is actually a bulk of the judging that takes place over finals week. Beyond the judging portion of finals week, we have different opportunities, both fun and enriching for the students. So we really say that it's the biggest prize of the competition is just being named a finalist and getting to come to finals week and have this experience. Students are able to connect with alumni through career panels. We do evening activities where we take the students to different places all throughout DC. We'll do monument tours, take them to museums. And it's really just a unique opportunity for students to meet other middle school students that are just as excited and passionate about STEM as they are, which you don't often get to have maybe in your area, in your school, where your students are. So the main criteria for the Thermo Fisher JIC is really assessing 21st century skills, communication, collaboration, creativity, problem solving. A question that we often get is, what are the additional steps to be selected as a top 300 or 30 finalists after submitting the application? There is no additional action. The application materials are what the evaluators and judges will review to select those top 300 and top 30. So if you think about the different aspects of judging that I've talked about, we like to say that the research project is kind of what gets the student in the door. That's what they've done at their science fair. That's the bulk of the application. But the application does also ask, go a little bit beyond their research project to think about enthusiasm and critical thinking skills. The students have a chance to highlight those skills within the application. We have some creative essays that we're going to talk about as well, in addition to the project essays that, again, are the bulk of the application. And then finally, at finals week, through the team challenges, the judges are going to be looking at how well the students work together, their overall breadth of STEM knowledge, but also their leadership skills. And are they coming together as a team and leading their team throughout the challenges that we do? So there's a lot of different skills beyond the research project that this competition highly values. A little bit more about the prizes and awards that are available. This is all available on our website too, so I'm not going to go through each award here, but our top award is the $25,000 Thermo Fisher Scientific Ascend Award. We have several awards that are top awards of $10,000 from different sponsors that each have different criteria. The criteria for these awards are based not only on the student's research project, but how they perform in challenges that highlight the skills that each of these awards are looking for as well. And then we have first and second place STEM awards. So that's science, technology, engineering, math for those four awards, first and second place, each for a total of 8 awards. First place winners get $3,500 for educational purposes and an iPad. And then the second place winners get $2,500 and an iPad. So throughout the years, we've spoken to a lot of different educators who have supported their students through Thermo Fisher JIC, just like y'all are trying to do this year with your students. And so some advice that we've gotten, that we've heard from, is to definitely encourage the students to start the application early. As soon as the student has earned their nomination and competed at their local science fair, this is when that information is going to be fresh for them. They've just talked about it extensively. They've just created their science fair, their poster boards for science fair. So it's going to be easier for them to translate that information into the written application. So we definitely recommend starting early. That also helps with the next two things here, which are offering support as you're able to, and sending reminders. So most teachers that we've worked with and heard from try to offer support before or after school. We know it can be difficult during class time to do other things other than the curriculum and the activities at hand. But if possible, offer just a brief period before or after school as a time for the students to come and ask any questions that they might have on the application, ask for any help with paperwork. We're going to talk about the scientific paperwork that we ask for in the application as well, or any kind of technical issues. And then sending the reminders and getting support from home really helps. We know that the application deadline is often after a lot of schools have already let out, and there's only so much you can do as teachers. There's only so much the students can do if they don't have access to, school-given laptops and that sort of thing. So definitely encourage them to start as early as possible, and then send those reminders and get support from whatever adults are supporting their students at home. We send these almost bi-weekly or more frequent emails to y'all as educators, and you can just forward those straight to the students. We do email the parents and guardians of our nominees for whatever data we get from the fair, but if we don't get emails from our fairs, then we don't have a point of contact. So as a safe bet, I think it's great to just forward our emails to the students themselves and to their parent and guardians to make sure that they're in the loop and they're getting all of the resources that we send in those email communications. And the biggest thing that we found really is that a student is not going to go far if they don't believe in the value of completing the application and entering the competition. So intrinsic motivation is definitely a huge, huge factor. If you're starting this journey with your students before even getting your students are nominated, or you're just thinking towards the future about how to get more students involved in science fair and research projects. Finding a topic that students care about is really key. There can be a science project pretty much made out of any question the student can find interesting to themselves. And if they have a tie, to the problem, if they're trying to solve a problem for their family, their communities, that gets a student excited and really interested in pursuing that scientific research project. And that enthusiasm then translates into the application. Another tip is to acknowledge nominees as much as possible at assemblies, in parent newsletters, kind of whatever avenues you might have at your school to do that external kind of motivation, right? That usually helps translate to that internal motivation that I talked about earlier. And it also helps get more students at your schools excited and uh, just gives them more information about the competition so that hopefully they're interested in pursuing science fair in the future. This next quote just talks about all the different kind of opportunities that open up once a student does decide to complete an application. There's benefits beyond just what we offer as Thermo Fisher JIC. It's an opportunity for personal growth, exposure to the STEM community, and future academic recognition. A lot of students find this to be valuable to put on resumes for either high school applications if they're looking to go into schools that require applications. It's practice for any kind of program that a student, might need to fill out an application to apply for down the line, college applications. So there are a lot of different benefits for just completing the application, in addition to obviously having the chance to become a finalist and compete at finals week. And then just to kind of get a better sense of what the competition is all about, we recommend watching our highlights video, sharing that with your students, maybe watching that together at an application work session, watching our alumni videos and sharing those with your students. Or if you have former nominees, former students that have made it to the top 300 level or even finalist level, definitely utilize them and their voices. We can say as much as we want that it's a worthwhile experience, but what really translates is students hearing it from their peers. So anyone who's been in their shoes, hearing their experience and how a lot of the times our alumni will say they had no idea that they would make it as far as they did in the competition. And so you really have nothing to lose by just applying and putting your foot out there. So we're going to transition into a little bit more about the application in just a minute. But as we get there, I'm going to hand it over to my colleague Jenna to talk about scientific integrity, what it means and how to promote it as you work with your students in research and the application. So take it away, Jenna.
Thanks, Reva. Really quickly, I'll just talk a little bit about myself first. So I got my bachelor's in biology from St. Mary's College. And then I went on to get my PhD in microbiology, but really I worked in an immunology lab at Miami University. And then I did a postdoctoral fellowship at the NIH, at the National Institute of Allergy and Infectious Disease in the Translational Immunobiology Unit, before coming to the society last February as the Scientific Integrity Officer. So one thing that we want to talk about is science today. So if you'd go to the next slide, Reva. Thank you. So I just put a couple of journal article titles in that's talking about what's happening in science today and scientific misconduct. And a really important thing is how do we know what's true in science? And this is something that is a challenge that science is facing today. Science relies on trust. So if papers are getting retracted, it's starting there and trickling all the way down to science fair and, middle school science competitions. And we need to kind of start early to foster good scientific practices. So if you go to the next slide. So, just to define scientific integrity, it involves conducting and communicating science with transparency, honesty, and accountability. It's not just fraud or bad science, but it is really important to foster trust. Like I said, without scientific integrity, we lose credibility and the ability to make informed decisions on reliable findings. We need to be able to trust that what we're reading is true and accurate. So we're going to work through a couple of case studies just as examples. We do this with applicants. This is something that we've been kind of sharing widely to try to give some knowledge and background information on scientific integrity. So the first of these is about image manipulation. Let's say that one of your students is completing a microbiology project that looks at the effect of pH on bacterial growth. And they do this and document their findings with photographs of the plates. Weeks go by and their science fair is approaching, and they notice that when they're putting their poster together, they can't find the images that they took of the neutral pH plates that showed bacterial growth. So what they do is they search online for pictures of petri dishes with bacterial growth that was similar to what they remembered seeing on their plates. So they edit an image that they find online to resemble their setup and image style, and they claim it as their own. So if you would just put in the chat if you think this is either A, appropriate, B, it's only appropriate if the image is cited as created by student, or C, it's not appropriate under any circumstance. So I will give that a second for people to put things in the chat. Um, so for this, this would not be appropriate under any circumstances. This is obviously taking credit for other people's work, and other people's images and data, and that is never something that we want to do. And we'll talk a little bit about this at the end, but some things that you can do as educators is start trying to do reverse image searching and things like that on things that are turned in by your students. A really quick, free, easy tool is Google Lens. That's something that we are aware of that you can use for reverse image searching and is a good way to start with this to see if students, if their images are found elsewhere. So if you go to the next one. So the next one is about reproducible results, and this is something as a scientist I really can relate to. Your student's science fair project examines the effect of a protease inhibitor on cell growth. They do 2 rounds of experimentation, and that generates the same outcome that's in support of their hypothesis and results in increased cell growth. However, during testing for the 3rd replicate, their cells died, even though the experimentation was seemingly identical. They decide to discard the 3rd set of results and proceed as if they did not occur. So similar to the last one, we'll see if you all think it's A, appropriate, B, it's appropriate, but if they do more, only if they do more testing, or C, it's not appropriate under any circumstances. So yeah, I'll give a couple seconds here. This is something that I feel like has happened to me many times, not the necessarily discarding of the results ever, but that one round just doesn't work out the way that you want it to. And I would say it's not appropriate under any circumstance. They still should do more rounds of testing, but they definitely do need to acknowledge that that 3rd round that was different happened, because sometimes maybe that was actually the correct round of testing, that was the correct result, and something happened differently in that one that got to different results. My grad school advisor always said that negative data always means something. You learned something, and even if it's not what you expect, a lot can be learned trying to figure out why something was different. So yeah, that one, I would say it's not appropriate under any circumstance, but they should also do more testing, keeping those results around though. Okay, for the next one, which is a hot topic right now, AI and research. So One of your students spends the summer completing a research project at their local university. They do spend hours in the lab each day collecting and analyzing their data. The time comes for them to put together their research report, but they are swamped with classwork, exams, and either high school or college applications. They quickly write their research report, but ask ChatGPT to provide a bibliography that supports their work. Um, so do we think this is A, appropriate? B, it's only appropriate if the full use of AI was disclosed, or C, it's not appropriate under any circumstance? So I'll give a little bit of time for the voting. So for this one, this would not be appropriate under any circumstance. We don't want students citing things in their bibliography if they didn't actually interact with the article itself. It's fine if they maybe don't have a ton of citations or sources that they used, but putting things in their bibliography that they never read or interacted with is never the correct option. We do want use of AI to be disclosed, and that's something that is becoming more and more popular, is disclosing how AI was used. I know a lot of journals are asking for that, and we are looking into doing that for our competitions as well. But we want to know how it was used, but having it provide a bibliography for things that they didn't actually read is not appropriate. So for our last one, collaboration. This is something that is also coming up a lot for us lately. So one of your students is inspired by the work being done in the department where their aunt works at a local university. Their aunt does not have time to mentor them, so she offers to have one of her graduate students serve as their project mentor. The project goes well, and they earn a nomination to apply for the Thermo Fisher Scientific Junior Innovators Challenge. Since their aunt only knew their mentor casually, they don't disclose that their mentor is a graduate student in their aunt's lab and that she is the reason that they gained access to the lab in the first place. So we're going to vote A, it's appropriate. B, it's only appropriate if they disclose the relationship between their aunt and their mentor. Or C, it's not appropriate under any circumstances. Um, so yeah, we'll give a little bit of time for this one as well. So this would be appropriate. It's fine. Get all the help that you can. That's what we tell our students. Science isn't done in a vacuum. We all need help. So this is appropriate, but we do want them to disclose the relationship between their aunt and their mentor. We want to know that that's how they gained access to the lab. That would never be considered as, a bad thing or having an unequal advantage or anything like that. We just want to know. It's fine. Everybody needs help. We all need help. We just want that to be disclosed. So with that, we're also going to talk a bit about adult support, and we shared this with the applicants as well. Some things that are acceptable or not acceptable. So one of the things that we say is acceptable is asking an adult to help proofread their application. This is totally fine. However, having an adult draft their application responses or copy sections of an adult's paper is not acceptable. So obviously, I think I had my mom read all of my stuff even when I was in grad school to proofread it, even though she's not a scientist. So having help is great, but making sure that our responses are our own, and not copying things, is really important. Um, Citing visuals taken and or created by the mentor and your visual aid is something that's acceptable. We don't have to cite things that are exclusively their own. However, if they use visuals that were taken or created by their mentor and then claimed it as their own, that is problematic, especially when we do reverse image search, and if we find it on the web as being credited to somebody else, but the student is crediting it as their own, that's where we run into problems. Having an adult review your citations is very acceptable. We've told them that that is perfectly fine. However, using the bibliography of a mentor's paper that was done with similar research is not acceptable. That's a bit like the AI one. We want things that we actually read and interacted with to be in our bibliographies. And then if they have their parent or guardian or science teacher help supervise their project in the classroom and write about it in the application, totally okay. What we don't want happening is them citing that an adult supervised their project when that did not happen. We want to make sure that everyone is safe and all risks are being accounted for, and making sure that that is actually the case. Um, so stepping back to AI usage, we want to talk about what we've been working on this a lot. We've put together, this is just an excerpt, but we've put together a AI usage guide that is in the ISEF educator's guide. Sorry, I forgot the word there. That is now available on the society's website. And this just goes through a lot of different options and whether this is acceptable or not, and under what conditions it's acceptable. So for like the first one, for example, it's going over things like asking generative AI to identify or summarize key points in an article before they read it, and then use that as a starting point for their literature review. This could be acceptable without explicit citation as long as that paper or article is actually being read. But if you want to find out if it's something that is actually relevant to your research, sure, getting a summary on that is totally acceptable. So this usage guide just explains the acceptable use of AI in projects and their applications. And we want to discuss that AI cannot be used to write application responses or to generate citations. It can be used in their research projects, but it must be cited properly. And this is in the ISEF guidelines for AI use that can be found in for the JIC application. So something else that has come up a lot is conflict of interest. And this is also something that we've gone over with finalists and applicants is kind of determining what conflict of interest is, and seeing, making sure that the students and mentors and teachers are aware of this. So what is a conflict of interest? It's when someone's personal interests or relationships impact their actions or compromise their judgment, decisions, or actions. This could be family, this could be friends, financial factors, or social factors. And something that we think is really important is that transparency is crucial when dealing with both actual and perceived conflicts of interest. Appearances is just important as reality. So disclosing any and all potential conflicts of interest is really important. You could go to the next one. Yeah. So some things to consider with this, and things, this is what we've gone over with the students as well as personal relationships. Are their parents or family members serving as their mentor? Have they facilitated the relationship with their mentor? Has access to a lab been due to familial relationships? And has this impacted any approval or safety processes? Also financial or resource-based conflicts. Did they participate in mentorship or academic-based programs, whether these are paid or not? And also if a company or organization is providing significant funding for their project, either directly or indirectly. So these are all things that we want students to be aware of and you all to be aware of, and to be disclosed in their applications. And finally, some information for you on how to teach integrity to your mentees. Some things that we have here are spending time, some class time on case studies, kind of like the ones that we did, scenarios, and have your class discuss. It's always interesting what the students think is appropriate and not, and what the adults think is appropriate or not. So it's always interesting to see their thought process on these things and kind of giving them the information to help them make informed and good choices. Having checks and balances throughout their research project experience is important to staying in tune with where they are. Check their logbooks frequently. Having check-ins or conference calls with their mentors, making sure that they're actually working with who they say they're working with. and having kind of summaries, either verbal or written, of their progress in a daily, weekly, monthly timeline. So also using detection tools as either your budget or your time allows, like I mentioned, there's a ton of reverse image searching software out there. Google Lens is a free one. There's a lot that the journals use that are publicly available. Plagiarism detection tools are also really important. Um, there are AI detection tools out there, though they're not always the most accurate, and it's really important that those are maybe just used as a data point and looking to see if there are any factual inaccuracies in their work. So citations is one of those things that we know that AI really struggles with. And that's something that we're working on trying to educate our audiences on. So yeah, using those kind of detection tools as you can, and then also considering what type of peer review is possible and productive for your mentees. So I think that is all for me. I'm gonna hand it back over to Reva.
Yeah, thanks so much, Jenna. And we hope y'all learned a little bit learned a little bit more. Sorry about that. About scientific integrity issues and the issues to be bringing up with your students. We want to emphasize this that it's important to kind of take a step back from the nitty-gritty of the application, the research, and just getting the paperwork done, and go back to, are we doing this in an ethical, safe way? And that's why it's really important for you all as teachers to help emphasize this material, these principles with your students as you're teaching scientific research. There's only so much we can do once they get to the application level and they've been nominated. We want them to be considering these things throughout their scientific research journeys. And so it's really important that they do understand a few of these points specifically for the application, like Jenna talked about. The AI usage, generating citations, but we know that citations are new for a lot of middle school students too, especially if they might be sixth graders. So this is where we really need the adult support in understanding this and helping to teach your students that are doing scientific research and entering our competitions. So thank you so much, Jenna, for talking us through that. And I'm going to hand it over to Alex to dive into the application a little bit.
All right, thank you, Reva. So we're going to go through some of the crucial things you need to know as an educator or adult supporting students to help them fill out their Thermo Fisher JIC application. So first things first, to help support your student to open an application, you need to know your student's fair password. So if we received your email as a contact from the fair, we've been sending you emails. There's the email that went out today, so probably a bunch of folks received that. And in those emails, if your student has not opened an application, it will have their name and their fair password in it. And they need that fair password to verify that they've been nominated to complete an application. So check your emails for that. And if your students don't know their fair password or you haven't been receiving emails, you can always email us at jic@societyforscience.org and we can help you get that information. You can also help them create an account. They should use a non-school email. We'll talk about it in a second, but the system that we use, the application system, the confirmation email sometimes gets stuck in school filters. And so to make sure that they're getting all the emails they need from us and can confirm their accounts and verify their accounts, recommend using a non-school email. Also, in case your students are eighth graders and are changing schools and might lose access to that email over the summer, if they're named a top 300 or top 30 finalist, they'll need to be able to get back into that application. And so retaining access to that email is important. You can go to the next slide, everybody. Thank you. So yes, so to open an application, the students will need to verify their account. Also, I recommend using a non-school email. So they will get a confirmation email, and the best way we recommend to make sure they get that email off the bat is to whitelist our IP address. The QR code here is a direct link to our accessing the application guide, which has a whole walkthrough of how to create an account and start the application including instructions to whitelist our IP address and the email addresses that the confirmation emails will come from. So it has instructions in there. Recommend walking with your students through that, following that process to make sure they get all the most important emails from us and they can get their application started. We can go to the next one. Great. So across many of our sites, in the application, across our website, there are many resources for students to help them in writing their application. So in the survey, in SurveyMonkey Apply, which is the platform where our application lives, there are citation resources for images and for their written work. PDF conversion resources. There are a couple places in the application, the parent permission form, visual aid, and paperwork that they will have to upload in PDF formats. There's some instructions to help them convert whatever file they have into PDF for those purposes. And also links to the application guide, to a lot of our external resources can be found there. On our YouTube channel, which luckily you have found if you are watching this live. From here, you can access our webinars that are for students and ones from past years, which are all still relevant. And you can also find walkthrough videos of each section of the application, including information about opening up your account and starting the application. So highly recommend if your students are looking for specific guidance on a certain section on where they should be looking for certain information, to go and look at those walkthrough videos. And our past webinars from this spring, our first one covers all the resources we have as a real deep dive into resources they can use all across the application. And then the one we did a couple weeks ago is a deep dive on part 3, scientific integrity, with a lot of the same material we covered today, and the visual aid. So if your students are looking for guidance for that, you can find that there. And through our website, you can find the official rules, the educator resource page, and a PDF of the application if you want to see what the entire application looks like and help your students prepare to fill theirs out. Go to the next slide. So the application consists of many sections. So the first of which, to get access to the entire application, they have to confirm their FAIR password. If they don't have it, again, email us. If they put in the wrong thing by accident, we can fix it. So just let us know via email. And so there's a couple of parts of it in the registration section, student experience, personal interests, where the students will just fill out information about themselves, how they came to be doing a science fair project, the school they go to, general information. Those are the easiest sections to knock out first. We recommend get those out of the way. And then from there, the project information section is the longest section of the application. And this section really is a written version of the interview they might have had at their science fair. So this will break down every single question we want to know about their application. They want to know about their project. And so this is where they can really get into the nitty-gritty of what they did, why they did it, and recommend looking at our other resources that have really done a deep dive into those for what to do there. And the visual aid is their visual aid to support their responses in part 3. So here's where they can put graphs and images, charts to describe what they've done to support those responses. And then part 4, which we'll talk a little bit more about in a second, those are also just an opportunity for students to tell us a little bit more about their interests, their journeys, and for our evaluators and judges to get to know them a little bit better. And then the science fair paperwork section, very important also. So this is where we are getting information about the safety precautions the student took, the parts, what they used or what they covered in their project that might have needed a little bit more supervision or pre-approval. And so this section will walk them through, and then we'll ask them to upload the science fair paperwork they uploaded or gave to their fair. If they do not have paperwork, they should reach out to their fair and see if they can get it. If they didn't have paperwork at all, they should have the person who supervised the project, so whether that is a mentor or a teacher or a parent, write a letter containing information about what they did, what supervision they had, what precautions they took. There's more details about this in the application, but that is a great section you can help your students review and make sure that they have covered all their bases to show us that they have done their project safely. Go to the next slide. Yes, so the project essays in part 3 and part 4, they should talk out loud, think through their responses for these questions. They're kind of meaty questions. There's big questions with lots of sub-questions, especially in part 3. So we recommend that they talk out loud to think through them. They really focus on why they did what they did. There are word limits for all of these questions, and so we recommend that they outline their responses or write them out in Google Docs or Word. One, to save their responses somewhere outside of the application, just in case they don't save or something goes haywire. So that they can also check their word counts and edit that down before putting it back into the application. And yeah, so you can see our previous webinars, walkthrough videos for a deep dive into what these sections look like. So the personal essays are really a chance to tell us about the students beyond the project they did. So a chance to showcase their writing skills. There's no right or wrong answers. And this is really telling us what's important to them. So there are a couple of questions that are required, and there's one that's optional. We ask them all to describe their STEM story, why they like STEM, why they decided to do STEM research project in the first place, and then ask a couple of questions about what is something that they learned recently that's interesting to them, or how do they like to spend their time, science or otherwise. Then we also give them a chance here to describe their personal story, anything that isn't included elsewhere that might be relevant to their application. So yeah, so the science fair paperwork section, important, yes. Do help your student get copies of paperwork they submitted to their science fair. Make sure your student talks about who supervised them, review their project, the safety precautions they took, and provide a letter if you don't have that paperwork available, and help them write that letter if the student needs you to. But you should not fill out paperwork post-fair. If there wasn't any paperwork filled out, it's okay, but you should write that letter instead. But if the student has no letter or no paperwork at all, they may fail to qualify. So definitely you can review that section with your students, but make sure that, like we were talking about in scientific integrity, it's important to be truthful about what your students did, what approvals they had, because that's what helps explain that they did their project safely. Next slide.
Sorry, and I'll also just chime in here. Thanks, Alex. Excuse me. Because I know we often get a lot of questions about the science fair paperwork from both students and the adults that are supporting them. So just to reemphasize, what Alex said, we give a lot of options in the application and in this section in particular for students to describe what they've done. So we break that down in questions. We have the letter that you can upload, like Alex said. So we really want to give all possible opportunities to the student to provide that evidence that they followed whatever protocols they had to do their research. So definitely help them with the section if they ask for it. But again, what we don't want to see, it's not going to help them to fill out any of the paperwork that may or may not have been required after they've already done their research. The point of a lot of that paperwork is to have review and approvals before they begin experimentation. That being said, we have structured this application in a way to still get the information and information that we need to properly review a student's project. So it's not necessarily the end of the line if a student doesn't have the paperwork. But this section will hopefully help at least describe and give those students the opportunity to talk about how they're being safe and who supervised them throughout their research.
Thank you,
All
Reba.
right, back over to you, Alex.
Of course. One final note on that. We accept any paperwork. So we know that some fairs use ISET paperwork, some fairs use their own paperwork. We will take whatever you got. So just important to send us whatever available documentation that your student has. So yes, moving on to some application tips. This is our application planner. It's available in the digital nominee packet that the fairs should have sent out to their nominees. If they didn't get it, they can email us and we can send it to them too. But this will help your students break down parts of the application, create deadlines for themselves, and make sure that they're doing things on time. So recommends where they start and then gives them deadlines and benchmarks where they can celebrate entering. And yes, just recommend that you have your students save their work often and save their work, especially for the longer sections outside of the application, so that you make sure that they don't lose any of their hard written work. And so some important dates. The application is open from February 1 to June 10th. Yeah, so June 10th at 8 p.m. Eastern time. The evaluation will happen over the course of the summer, and the top 300 junior innovators will be announced on September 2nd. 2 weeks later, the top 30 finalists will be announced. And then finals week will be from October 23rd to 28th, 2026 in Washington, D.C. We'll have our Science and Engineering Project Showcase, which is both an in-person event, and we will have an online version as well, October 24th, 2026. So some resources for educators. So our JIC homepage has lots of links and connections to lots of resources. We have specifically a page on our website for educators, so definitely check that out. You can find affiliated fairs in your area via our Find a Fair tool. And you can sign up for the Middle School Research Teachers Conference Lottery via the link there. We'll link a lot of these in the caption of this video after we are done here today. But this is another opportunity for middle school research teachers. And I will pass back to Reba to finish us up.
All right, thanks so much, Alex. So I'll actually leave it on this page here in case anyone wants to take a screenshot or a picture of these links, but you can access all of these just from the societyforscience.org webpage. So that's your one-stop shop for a lot of resources that will help you not only with the Thermo Fisher JIC, but learning about all the other work that we do. And also highly recommend checking out the different outreach programs that we have available that are designed specifically to help teachers that are supporting students through research. So there's a lot of resources available there. We have different grants that we offer to science teachers for things like equipment that can help in their classroom, to offering stipends to teachers that work with students already in the research process, and help those students enter in competitions. So definitely check those pages out. And we will take some questions. I think I've only seen one question come through about the slides for this. We aren't going to be sharing the slides, but this webinar through this link that you have already will be available to you anytime that you'd like to reference it. And again, definitely would recommend checking out our other webinars that we have on our YouTube channel as well. So I think that wraps up the questions that we got live. So if you have any other questions that come to mind as you watch this back or check out any of our other resources, definitely send an email to jic@societyforscience.org, and we'll be happy to help you out. Thank you all so much for joining us today. I know this is taking an hour out of your evenings, and as teachers, which I'm assuming most of you are, and parents and other adults supporting students, it's just a busy time, and we know that supporting students through the application and in research in general takes a lot of your time and effort. So we really just appreciate all you do to help your students out, and hope that your students do end up applying to Thermo Fisher JIC. It's a really unique opportunity, and we hope to celebrate them at every step of the way. They've done an amazing job already just by completing a research project and earning that nomination to compete. So we hope that they are just encouraged and motivated to continue their research, both through completing the application, but as they move on through their the rest of their middle school and high school careers. So with that, we will say good night. Take care. Thank you all so much, and hope to see your nominees in the application. Bye, everyone.